So 2.4 is going to conclude our discussion of sets in Chapter 2. We're going to take a look again at Venn diagrams. And I mentioned on Wednesday last week when we talked about Venn diagrams that right now it sort of just looks like a puzzle. We were just sort of shading things in, filling in a puzzle. Maybe it felt a little bit like a Sudoku or something like that without any real purpose as to the why. The purpose as to the why is today. So these are true application problems that show how Venn diagrams can truly be used for certain contextual situations. So we're going to start first with the cardinal number formula. The cardinal number formula tells us how we can count items in sets. So it says that the number of items in the union, A union B, is equal to the number of items in A plus the number of items in B, and then minus the number of items in the intersection. And that needs explanation because it kind of feels a little counterintuitive to begin with. So I realize it's also been almost 5 days, I guess, since we've talked about Venn diagrams. But the thing that you need to remember is that when we're counting the number of items in set A, it's this entire circle A, which means the 3 and the 6 get counted. These 3 and the 6 now are no longer regions like we used before, but they're representing the number of elements inside of that area, right? So if circle A was representing a certain type of music maybe, and circle B was another type of music, and you had 6 items that could be categorized in both ways, they would be in the middle. The number of items in set A would include both the 3 and the 6. So if all the items in set A includes everything here, and then you count up all the items in set B, that counts everything here, what happens to that middle sliver? You get counted twice, right? You counted it when you counted circle A items, and you counted it when you counted circle B items. So what you see up here is that we have to remove the double count. So that's why that's showing up that way, is because it gets counted twice when it's in the overlap. We won't need this on every problem, but when it shows up, we will have it to use, and I'll make mention of it so you can see how it's utilized. Okay? So we're going to take a look at this diagram. I'll take out my shading, and remind ourselves what these symbols all mean. Okay? So we're taking a look at A intersect B, A union B, A prime intersect B, A intersect B prime, and then A prime intersect B prime. Okay, so the first two are the easiest ones because they don't have any of the prime notation. So this one says we want to look at the intersection of A and B. So where is this visually on this diagram? Where is the intersection of A and B? It's the 6. This piece right here is the intersection, right? So when we're doing this piece over here, this says use the numerals representing cardinalities to give the cardinality of each set. So what we're actually finding is the number of items in A intersect B. That's what we're finding. And you guys just told me it was 6, and that's correct. Now the next one says union. What does union mean? All of it combined. And while we do have a cardinal number formula for union, we don't need it here because we can see the 3 pieces that are combining union or the sets A and B together, right? They include the 3, the 6, and the 2. So if I were to count all those up, that's my union. How many items are in the union? 11. Right? 3 plus 6 is 9, plus 2 is 11. So those 2 are the most direct because they are the actual sets. The next 3, we haven't talked through the reasoning pieces of these quite thoroughly yet, but we will now. We're going to take a look at what happens when we look at the intersection with some complements from a concrete point of view for areas. So if you'll remember, this notation means things that are not in A. So in my circles, and this is a whole diagram in the Venn diagram right now, which values are not in A?
2 and 7.
2 and 7. These are the items that are not in A. Correct? And this says I want to intersect it with the items that are in B. Which one would those be? Is it 2 and 7, or is it one or just the other? Okay, so the items that are in B are 2 and 6. That's true. So let me actually shade that a different color. 2 and 6 are the items that are in B. But I want the intersection of those. So that would simply be the number 2. In other words, where does the shading that was yellow and the shading that was in white overlap? Which one was double shaded? Because it was intersection, right? It was overlapping and double shaded when I shaded in the 2. Okay, we're going to try again for another one. This one now says A. I'll shade it in yellow. So which of those numbers do you see showing up in set A?
3.
3. Any others?
6.
And 6. 3 and 6 are both in A. And then this one says that I want this to overlap with the things that are not in B. So which values are not in B?
3, 3, and 7.
The 3 and the 7. Okay? And I want the intersection. Intersection means where they overlap. What do they have in common? So which number did I double shade?
3.
3. So this one's 3. Okay, the last one says I want the things that are not in A. So what values are not in A?
2 and 7.
2 and 7. And then it says that I want the items that are not in B. So what values are not in B?
3 and 7.
3 and 7. And what I'm looking for, again, is the overlap, because this is still intersection it's asking me for. So which item was double shaded?
The 7.
The 7. So what we're doing still feels a lot like what we did before, a little bit more concise, okay? And we're taking a look at how these intersect, but the numbers mean something different. The numbers are actually representing a number of items and not just a region. So what that means is that some of these numbers might actually be the same, right? I don't have to have them all different. These were, because it's an introduction problem, I don't want to confuse the issue. But they don't all have to be different in order to do this problem, because they're not representing regions, they're representing items or elements in those sets. Let's take a look at another one. This one doesn't start out with a Venn diagram, right? It actually gives us some information to start with. It says to use or to make an appropriate, I think it's supposed to say make use, yeah. Make use of an appropriate formula to answer the question asked. We only have one formula, right? It was right over there, at the very beginning. So this is the formula it's referencing. So I'm just going to write it down for the moment. A union B equals the number of items in A plus the number of items in B minus the number of items in the intersection. And they give us some items, right? So we're going to fill this in like an algebra equation we would, right? They tell us that the number of items in A is 8. So right here, I write 8. And they tell me that the number of items in B is 14. So right here, I write 14. They tell us that the number of items in the intersection is 5. So this is a minus 5 because there's a subtraction sign at the end. And I can use this now to find the number of items in the union. So what is 8 plus 14 and then minus 5? 17 is it, yeah. Okay, so we're using that formula so that we can actually find the union when we know the intersection and we know the number of items in the set. Now, I'm going to do something on this problem that doesn't ask for, simply because we're going to be using this idea in a moment in a different problem. You could equally be asked to fill in a Venn diagram showing all the different pieces using these 3 pieces of information. So let me show you how that would look. So if we were working with a Venn diagram here, and I have my circle A, and I have my circle B. So here's A, here's B, and here's the universal set. The fact that the number of items in A is 8 does not put an 8 out here in circle A. Because there are two pieces of this picture, namely the circle A on the outside part and the overlap part, that both have to include the 8. So if you think about it and you were just working with trial and error, this could be 8 and 0, it could be 7 and 1, it could be 2 and 6. There's lots of possibilities, right? Not like infinitely many, but there's more than I want to play with trial and error. Agreed? Yeah, there is. So finding out or using the information that the number of items in set A is 8 or the number of items in set B is 14 is not a good place to start here. The part where it's good to start, though, is knowing that the number of items in the intersection is 5. Because that is one very specific area of this graph. It's the overlap. So if I have a 5 here in the middle, now I can actually use the fact that the set A has 8 items in it. I have to have a number in this outer region of A so that when I add it to 5, I get 8. What goes outside here? 3. And I can do the same thing for set B. So the number of items in set B is supposed to be 14. 5 of them are already accounted for in the overlap. So how many are missing out here? 9. And if we double check our work from the equation perspective, we should add these 3 together and get 17. Do we? We do. Now, I've got an incomplete picture here because I don't know what goes out here in the U. I mean, right, this is not a complete question, but this isn't what the question was asking. But I wanted to show you that if you don't like the formula perspective from an algebra perspective, you can also think of it from the picture perspective, which we'll need to use later anyway. Okay? All right. So we have one more where just some numbers are given, and they're going to feel kind of like the problem I just did at the bottom here with the Venn diagram part anyway. They give us a bunch of numbers, and they want us to draw a Venn diagram that works. Okay? So we've got the number of items in A, in B, in C. We've got some intersections of 2 sets, and we've got one place where we have an intersection of 3 sets, and then we have our universal set on the outside. Or to figure out what's going to be missing from the outside. So jot yourself down a note that what we want to do is we want to start with overlapping regions. And we're looking for a value, we'll say it that way, a value clearly defined. And I'll show you what I mean by that as we draw our picture. So, how many overlapping circles am I going to need? 3. Okay, there's an A, B, and a C mentioned, right? So some of our problems have 2, some of our problems have 3. So we're going to draw 3 on this one. Okay, and as always, I'm going to label mine straight across, A, B, and then C at the bottom, and U on the outside. Now, we are given a lot of information up here, right? But not all of it is a super helpful place to start. In fact, most of it's not. We talked about the fact that this region for A is not super helpful to start on our last picture, and it's even less helpful to start here. Because region A has 4 regions, right? This is the region on the outside, the overlap with B at the top, the overlap with everything in the middle, and the overlap with C at the bottom. There are 4 different pieces, and they're all supposed to add up to 24. And while you might have been okay with doing trial and error with 8 on my last picture, I'm really thinking 24 would be a bad idea with 4 regions. We don't want to start there. That's not what it described here. What I described here is a clearly defined value. That's not helpful. And if A is not helpful, obviously B and C are not helpful either for the exact same reason. Now, you might be looking and saying, okay, well, last time when I talked about this one, I said, okay, well, that A intersect B was a good place to start. So maybe A intersect B is a good place to start here. And it's getting better, right? A intersect B is 10. But the problem is that A intersect B intersects in this top, and it intersects in the middle. So there's still 2 places where A and B intersect. Right? This whole overlap is A intersect B. I'd still have to play trial and error with that number to figure it out if that's where I start. So that's not where I want to start either. It's not a clearly defined value. And if A intersect B is not clearly defined, neither is B intersect C or A intersect C. None of those are good. So what you're looking for is you're looking for this one right here because it defines all three sets in the same description, okay? And it very specifically tells you what to put and where. I'm going to use the number 6. Where is it going to go? In the very middle. Now, they don't always go in the very middle. That doesn't have to be what happens. It could have said A intersect B prime intersect C. Well, instead of being the overlap of all three, I need to make sure I'm not in B while I'm in A and C. Okay, so there might be something like that going on. But oftentimes it is one where it gives you the overlap of the three sets, and it is the center value where you actually start. So that's my 6. So I'm going to mark these out as we go. We did this one, okay? And then we're going to go sort of up from there. This, I didn't say it yet, but this number of items in the universal set 50 is the worst option because that means all the numbers combined. There was 8 regions, right? So I don't want that one right here, this in a view, is going to be the very last thing I deal with because it's going to have to specify all 8 regions, and I need to know 7 of them before I can find the last 8th one, okay? So we're going to work our way kind of back up. You can start over here at the A intersect C, and we can just flat out go backward, or you could go up to go A intersect B. It doesn't really matter. I'm going to go flat out backwards. So this A intersect C says it's supposed to be 15. So A intersect C is down here, right? These two pieces that are shaded in green have to add up to 15. There's already 6 in the middle. What do I need? I need a 9. So there's now a 9 over here, and I've taken care of the A intersect C.
So it don't have to equal 15?
It does, because 9 plus 6 is 15.
Oh, okay.
Yeah, so it's the two regions added together that we want to be 15, not just this little piece over here. Yeah, that's a really good point because that's a very common mistake. Very, very common is to see the intersect and just look at the one little piece where only those intersect. But it's not only, it's both.
So could we just, no, we couldn't.
Okay, that's all right. Okay, so working our way backwards, now we have B intersect C. Well, B intersect C is over here, right? It's supposed to add up to 8. 6 are already accounted for in the middle, so what am I missing? 2. So I need a 2 right here. And once I've done that, I'm going to sort of rule out that I've taken care of that piece of information. There's one more of the intersect. It's A intersect B, which is, whoops, the right shading, this one. Supposed to add up to 10. 6 are accounted for in the middle. How many am I missing? 4. So I have 4 right here. And I've taken care of this piece. Okay, so we're sort of working our way from the inside out. And again, it doesn't always start in the dead center, but sometimes it will, many times it will. Okay, and we're trying to piece things together as we sort of build on what we know. At this point, what's very nice is if you notice any of the individual circles, like look at circle A itself. There's 4 regions and 3 of them are filled in, right? And the same thing's true for circle B and for circle C. All of them have 4 regions and 3 of each of their 4 regions are filled in. What that means is that very top line where it tells me how many items are in A, how many items are in B, and how many items are in C can all now be used very specifically. So we'll start, again, I'm just going completely backwards. So we'll start with the number of items in C is 26. Okay, so circle C is down here. Right now I've got a 9 and a 6 and a 2. How many do I have total already in circle C? 17. And I'm supposed to have how many? 22. I think it's more than that. 26. Yeah, 26. Sorry, I was zoomed in. So 26. So I have 17 and I need 26. How many am I missing? 9. So we're going to fill a 9 in on the outside of circle C. And we're going to mark out that we've taken care of circle C. Same thing for circle B. So circle B is this top one right here. I've got a 4, 6, and 2 already in the circle. How many is that total? 12. How many am I supposed to have? 24. So how much is missing? 12. And I've taken care of circle B. Okay. Now we've got our 24 for our circle A. So circle A right here is a 9, 6, and 4. What is that? 19, and I'm supposed to have 24, so I'm missing 5. Okay, so this is the first section that I think it really is sort of beneficial if you have your calculator with you. So if you have a calculator with you, go ahead and grab it. Because what we need to know is we need to know what's still going on out here, right? What number is missing on the outside? And in order to do that, we need to know that the number of items total in this diagram should be 50. We got to figure out how many we've taken care of already. So we need to add up the 5, the 4, the 12, the 9, the 6, the 2, and the other 9, and figure out how many we have. And it better be less than 50, otherwise there is a mistake and we got to go back and find it, because it's not possible. So, what does it add up to so far? Anybody get it?
47.
47 is right. Okay? So if the numbers that are already there add up to 47 and it's supposed to be a total of 50, I'm missing 3. So 3 goes out here. Okay, so I keep promising you we're getting to application. And so far it still feels like it's a puzzle. But it's the next problem. Okay? So all these pieces filled in, we need to know how to do that in order to be able to use these problems for application. Any questions on the filling in of the diagram? Okay, let's take a look at an actual example. Got a type on my screen here too, good grief. His name is long. Okay, we're going to use the Venn diagrams to work each problem. Have a couple of examples, maybe 3, maybe 2, I can't remember. 2. Where we're going to see these problems applied. So we have Joe Long, and he writes and he produces albums for musicians. Last year, he worked on 10 such projects. He wrote and produced 2 projects. He wrote a total of 5, and he produced a total of 7. Okay, pretty good so far. So we're going to draw a Venn diagram, and the first decision that we have to make in our Venn diagram is, do I have 2 circles or 3? So what do you think?
3.
There's 2, actually. So why would 2, for those of you who thought it was 2, why 2?
Because it says because he wrote and produced, so that's the center section.
Yeah, so there's actually only 2 descriptions for Joe. There's descriptions talking about things he's written, and there's a description talking about things that he's produced, and there's not a third category. There could have been a third category, right? I mean, we could have a third thing here, but we don't. All we have is the wrote, okay, let's get the right pen, and the produced. Okay, those are the only 2 categories. So as we draw our diagram with our 2 circles, you're welcome to label them with A's and B's and so forth. You're also welcome to label them with the description of what they are. So I'm going to label them with the description. This is my circle where he wrote things, and this is my circle where he produced things. And then this is the universal set on the outside. Okay, if I label it that way, then I don't have to remember what was A again, what was B again, so I kind of like doing it that way. Okay, so Ava, right? So Ava pointed out that there's the first one right here is actually a really good place to start when she was thinking about how many circles. And it's a good place to start when we're thinking about putting the numbers into the circles as well. And the reason it's a good place to start is because of the word and. Okay, so what does the word and mean when we're looking at a Venn diagram?
It's going to be between somewhere.
Yeah, it's going to be an overlap, right? So the word and is equivalent to the intersection concept that we've been working with. Okay, so when we see and, we need to think intersection. And intersection, when we're looking at a Venn diagram, is overlapping pieces. So the overlapping piece on this diagram is the part where I'm going to write the number 2. Because that 2 represents items that he both wrote, so it's in the wrote circle, and he produced, so it's in the produced circle. Does that make sense? Okay. If we go down our list next, we've got one where it says he wrote a total of 5. So again, the temptation is to put a 5 in this outside circle. That's not what we're actually supposed to be doing, because what we want is we want the whole circle to add up to 5. And I already have 2 of them accounted for. So how many are going to be written now in my outer circle? 3. And then they do add up to the total of 5 projects that it specifies right here. Okay? The third piece of information, and it's the last piece in these sort of bulleted spots, says that he produced a total of 7. So produced is another circle, okay? Has to be total of 7 in that circle, but there's something already in that circle. 2, right? So I don't put a 7 in the outer region. What number will go in the outer region? No, 5. There will be a 5. Why is 5 in the outer region?
Because he wrote and produced 2.
Yes, because I already put 2 of them in there. So now the 2 in the middle and the 5 on the outside will add up to the 7 that is the total that he produced. Okay, everybody good so far? What's missing?
The 10 on the outside.
The number on the outside, okay? And there is a piece of information that we haven't used. Do you see it? Look back over the entire problem. What have we not used?
10 such projects.
The 10 such projects at the beginning. He's done something with 10 projects. 10 projects, right? So if you take a look at the numbers that we already have here, what is the total? The 3, the 2, the 5 is already a 10. So what does that mean is going to go on the outside of this one? It's actually going to be a 0. So it's perfectly acceptable for 0 to be in one of these spots. You can't put negatives, because you can't work on and produce and do things with negative numbers of things, right? These are numbers of items. So I need positives or 0, but 0 is perfectly fine. Now, if it said that he worked and produced a total of 12, right, not 10, but 12, we would still have a number on the outside here, right? It would be a 2 in that case. So it just depends on the numbers that we are given. So what's the point? Well, the point is that if I put all the numbers in the Venn diagram appropriately, right, if I do that work, then it's very easy to answer these questions. So I'm going to copy my diagram and move it to the other page so that we can see it too. So once I have my diagram, these questions answer themselves. This says, how many projects did he write but not produce? That's 3, because it needs to be in the right circle, but not in the overlap, because those are the produced items as well. How many did he produce but not write? That's my 5. And how many did he not write or produce? That's 0 on this one. Okay, so the questions are fast. That's not the hard part. The hard part is creating the Venn diagram from the information given, at least the lengthier part. Okay, so this had 2 circles. So what do you think we're about to do? More, 3. Yeah, 3 circles. Okay. So here's an example of one. A lot of information. So at the University of Louisiana, half of the 48 math majors were receiving federal financial aid as follows. 15 had Pell Grants, 14 were in college work study, 4 had TOPS scholarships, 2 had TOPS scholarships and were in work study, and the last thing says those with Pell Grants had no other financial aid.
First is 5.
Oh, do I have a typo?
Yeah, Pell Grants.
5 for Pell Grants. Yours is right then. There's a typo on the screens here. I'll get them fixed before my next class, and they won't even know that they were mistakes. It's going to be amazing. Thank you. Are all the numbers otherwise okay? Yeah? Okay. Okay, so can we see why there's 3? I know I spoiled all the fun in making you count before, but do you see why there are 3 circles? What are my 3 circles?
Pell Grant, work study, and TOPS.
Right, Pell Grant, work study, and TOPS. There's 3 different categories of things mentioned. That's why I have my 3 circles. Now, I don't have enough space on my screen here. I'm going to have to keep flipping back and forth, so you might get dizzy if you look at my screen too much. So your paper's got all of it written down. But we're going to draw a picture with 3 overlapping circles. That's not too bad. Shift it up a little bit. Okay. And I'm going to label them the same way that I just verbally described, or that actually Ashton just verbally described. We're going to have Pell Grants, so I'm just going to call it Pell. We had work study, so I'm going to call that WS. And then we had tops, right? And we have our universal set on the outside. There's actually a couple different places that we could start on this picture based on the information given. So I'm going to flip back to our information given. There are 1, 2, 3, 4, 5. There's 5 descriptive phrases that are bulleted. And then I have my half of the 48 business up at the top talking about people receiving financial aid. So looking at that, let's just talk through pieces that are maybe not helpful. The 5 in the Pell Grants category typically would not be helpful. And the reason is because it would include all 4 of these regions, right? Typically, that would not be a good place to start. However, there's another piece of information on here that actually tells us we could start there. That piece is at the bottom. It says that those with Pell Grants don't have anything else. What does that mean? Well, it means that everywhere that Pell Grants is overlapping with the work study and with the TOPS, those are zeros. If they have Pell, they don't get the rest. Is everybody making sense of that? Okay, so we're going to put a 5 there in just a moment, but let's actually go through a couple others. It says 14 are in the college work study. So the college work study would be this one, again, 4 regions. And I don't have any descriptive like, and there's no other overlap like the last one, so that's not a good place to start. I have 4 that have top scholarships. Again, that's this outer category here, 4 regions, probably not a good place to start. And then the last one that I haven't talked about is that the 2 have top scholarships and are in work study. So again, visually from the picture, that would be these 2 pieces, and they overlap in 2 regions. So you're trying to decipher from the information which eliminates everything but one tiny little part. And one of the places where I've eliminated everything but the tiny little part is because the Pell Grants have no other financial aid. So on this diagram, it can actually fill in the 5 here and zeros in all these places, like that. Because the Pell Grant cannot overlap and have anything in it. Because if you have a Pell Grant, you don't get work study. If you have a Pell Grant, you don't get TOPS. That's really nice because that filled in quite a few pieces of our picture automatically, right? There's actually another place. We can actually continue this problem from here, but there's actually another place that we could have started as well. Over here at the very beginning, on this one, it told us that half of the 48 majors were receiving federal financial aid, right? So if half are receiving federal financial aid, then that means that half, what? Are not, right? Half of them are not. So what does that mean in terms of my picture? Well, over here, it means that I want to make sure, at least as I write this down, that I don't include all the 48 here. Only half of them, namely 24, because that's half of 48, are in this picture. So I could start by identifying and making sure I understand that I don't really have 48 in this diagram. I really only have 24 in this diagram because my diagram as a whole is everybody receiving federal financial aid. Now, there are other forms of federal financial aid. Does everybody understand that? They've given us 3 descriptors, but they didn't say that that's all there is and nothing else. So this outer region we have are still receiving federal financial aid. It's just not one of these 3 types.
Can we just go ahead and write 24 on the outside?
We can't. Because the 24 that we just eliminated are out here. They don't have federal financial aid. My whole diagram as a whole is going to be 24. So there is going to be a number on the outside that's going to complete the picture here at the very end, but it can't add up to 48. It only should add up to 24. Does that make sense for everybody? It's kind of a weird one with this piece because of the way they described it to begin with. Okay, let's go back and we will work our way through the list. So we haven't taken care of the 24 yet, but we've identified we do need 24 in the whole diagram, not 48. All right, so the 14 in college work study is still not a great place to start because I still have 2 regions in work study, namely the outer region and the overlapping TOPS region that I don't know. So I don't want to start with the 14. The 4 in TOPS scholarship has the exact same problem, right? There's still 2 regions for TOPS scholarship, so that's not a good place to go next. So what should I be using next? Yeah, this 2 right here. The 2 that have TOPS scholarships and have work study. So over here, that puts a 2 right here. Okay? So, looking back at our list of things, I can do either of the pieces that are left now. We'll start with the first one this time. Work study, supposed to be a total of 14. I have 2 of them on my diagram already, right? So 2 of them are on the diagram already, so how many am I missing right now? 12. So there should be a 12 right here, so that my work study circle all adds up to the 14 it described. Okay? How about the top circle? What's it supposed to total add up to? 4. And how many are already accounted for? 2. So I need 2 more. Okay. So this isn't quite as many different numbers going on here. Probably do this in your head a little quicker than the last one. But how many do I have accounted for right now? 12, 2, 2, and 5. 21. How many are supposed to be in the whole picture? 24. So how many am I missing? 3. Okay, and this is the other 24 people that didn't have the federal work study. It doesn't really need to list it anywhere, but that's where they went. They went outside the rectangle. Okay, any questions on the creating of the diagram? Because if the diagram gets messed up, all the numbers afterwards are going to get messed up. Okay, so then, we already answered one question, the first one, A. How many of the 48 math majors had no federal aid? That was the 24, the number I put on the outside. It's 24. How many had more than 1? 2. So more than 1 would be anything in the overlaps, right? We didn't have that kind of a question last time because the diagram didn't have 3 circles. But I would have to add up all of the circled overlapped pieces. We just have a bunch of them that are zeros this time. So if those zeros weren't there, we'd have to actually add them in as well. So more than 1 would include all of these pieces. And for us right now, that's just the number 2. So there's 2 that had more than 1 form of aid. How many had federal aid other than these 3 forms? 3. That's the people that are over here, right? Federal aid, but not one of those 3 types. And the last one says a TOPS scholarship or work study. So what does that word or mean? What was that, Jordan? It's not and. That's important. What?
All of them combined.
It's all of them combined. Okay, so write somewhere on your paper, because this is really important. And or have very different meanings. And means overlapped, right? We've already encountered that today too. Or means you combine all the pieces. So when we look at or, we're talking about this whole pieces combined, right? It's all of it, right? Remember, it's that marriage ceremony issue that I talked about last time. You get it all. So you get the 12, you get the 2, and you get the 2. And you get a bunch of zeros as well, but those don't add anything. So if I add them all together, what do I have? 16. So there are 16 that have one or the other of those types of federal financial aid. Yes, sir.
If it said and.
Yes.
then what would you?
If it said and, so if it said that they have work study and top scholarships, what's that answer? 2. It's the overlap. They wouldn't ask it on this one because that's one they actually gave us, but given different information, they certainly could ask it. Yeah. So and means overlap, or means you get all the pieces added together. Okay. Any questions? All right, that's it for today.